Hi, welcome to Amazing Science TV. My name is Peter Dennis. So in the last videos we were talking about ionization energy and we talked about its trend across the period. So today we are going to be looking at its trend, the trend of ionization energy down the group. So what is ionization energy? To make a recap, ionization energy is the minimum amount of energy required to remove the most loosely bound electrons from the outermost shells of a neutral gaseous atom to form a positively charged gaseous ion. So also, to make a recap of what we looked at, factors that affect ionization energy, we say nuclear charge, screening effect, and atomic radius. So, what we are going to take a consideration of group 2, which has beryllium, magnesium, calcium, strontium, and barium. These, what are put in brackets here, those are atomic numbers. Beryllium has atomic number 4, magnesium 12, calcium 20, strontium 38, and barium 56. So, as we check here, we see that beryllium has 899 as kilojoules per mole as the ionization energy. Then calcium has 737, this one has 590, 549, 503. So we see that the trend generally decreases down the group as we move from top to bottom. So that is the trend of ionization energy down the group. As we move from top to bottom down the group, generally ionization energy decreases. So what could be the reason why ionization energy follows that trend? So we are going to look at the factors. What happens to the factors down the group? Nuclear charge, we talked about it as the attraction of the nucleus for the outermost electrons. Then we will say that screening effect refers to the repulsion of the electrons in the inner shells against those in the outer shells. Then atomic radius, we said it is the distance of closest approach to the neighboring nucleus. So, how do these vary down the group? So, as we move from top to bottom down the group, nuclear charge goes on increasing. As screening effect goes on decreasing. Yes? And so electrons, as we move from top to bottom down the group, the screening effect goes on increasing. Why does it increase? We see that shells are being added. When you check on this, we see we have, now that for beryllium, we have, if I'm to use the format of O level, beryllium that has 4, we see that we shall have 2 to 2, isn't it? Implying those are 2 shells. Then for magnesium that has 12, we see we have 2 to 8 to 2, and these are 3 shells. So this calcium that has 20, we see that it is 2 to 8, this is for calcium. It is 2 to 8 to 8 to 2. So we see these are 4 shells. So as we move down the group, the number of shells are increasing, implying that the screening effect goes on increasing from top to bottom down the group, as nuclear charge goes on decreasing. So what is happening? The effective nuclear charge will be too low, and in so doing, the electrons in the outermost shells will be pushed away. They will be far away. The attraction, they will not be attracted to the nucleus, and in so doing, the atomic radius will go on increasing down the group. So that's why we see the trend following that ionization energy goes on decreasing down the group, because the amount of energy that will be required to remove the outermost shells, since they are pushed far away from the nucleus and the size is too large, then they will require less energy to be removed from those shells as we move from top to bottom down. That's why we see the radius is low. Since the atomic radius since the atomic radius is small, that's why the ionization energy is too high. Then magnesium also has a slightly low, the small atomic radius. That's why we see it has a higher ionization energy compared to calcium, and that's why the trend follows that way. So generally the trend down the group, the ionization energy goes on decreasing simply because the nuclear charge goes on decreasing as screening effect increases, and the effective nuclear charge will be too low, and the electrons in the outermost shells, they will not be pulled, they will not be attracted to the nucleus. They are pushed far away from the nucleus, increasing the size of the atom, and in so doing they will require less energy to be removed. The electrons in the outermost shells, they will require less energy to be removed from those outermost shells. Thank you so much for watching. Subscribe, do not forget subscribe to my channel Amazing Science TV. Like the videos, share the videos with your friends. Do not forget also to hit the notification so that you'll be getting the notification of the subsequent uploads. Then also comment in the comment box. I will take heed, I will take note of all those comments. Thank you for watching.